All right, so I'm here today to talk about auth-n and auth-z. So all auth is the same, right? 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 No, it's not. Not even close. Let me make sure that I'm able to advance the slides here. Oh, yes, good. All right, so before we get into that, as Heidi was talking about, we are not at Black Hat, but we are still people who have the ability to create change in our organizations, right? So you are it. The people in this room are it. I firmly believe that we are the change makers in security of our systems today. And here's why. Every DevOps person, every platform engineer, every SRE, every infra engineer, whatever you consider yourself, I've ever spoken to or have ever known or have ever worked with, knows and understands their systems and environments that they work in intrinsically. So you are all, you people, run everything and make everything run better. You're the ones who really can make a difference. And sorry to all of the VP and C-level types here. I really appreciate your assumption of risk in our organizations, but we're really sick of all of the really crappy platforms you hand down to us, quite honestly. So if you could just stop doing that, because they're a pain to run. And we can just start using more developer tools that we know run well, that would be great. So listen to the people in this room. If you are a VP, if you are a C-level, the people who run the things, we know what we're talking about. And it's time that more organizations start listening to DevOps folks. We're the ones that are the doers and the do-betterers. We're the people that write the code to make the products work better, which gets more money in the door. And we're the people who know how to scale applications and make them truly high availability. So my wonderful DevOps engineers and the like, this talk is for you, the true game changers, the true change makers. Let's talk basic, boring, and absolutely needed concepts and tools for authorization and authentication. All right, so I guess I should say a little bit about who I am. I am Jenessa Petersen. I am a Minneapolitan at heart. I live on the south side. That way, I'm really bad with directions, but I love cats when I am not working, doing technology stuff, working specifically within privacy. I am often with the Bitty Kitty Brigade, so taking care of neonatal kittens and all that kind of stuff. That's what I do for fun. So I also believe that technology has kind of taken a step back. We had the emergence of APIs, we have all this automation, but there's still really a human factor in technology, and so bringing that human factor to the forefront of technology and that authenticity that can really be part of technology is something I really believe strongly in. And then I also believe that privacy is a human right, and thus have found myself in the boring parts of infrastructure, really boring parts of infrastructure for my entire career. So that's what I do. So these are the places, giving a little bit of my resume, and hopefully I'm a little bit of an expert on these two things. Where I've put my 40 hours a week was at CoreOS. And the early days of Kubernetes there, and basically all of that free and open source software that we often use to run Kubernetes today, a lot of that came from CoreOS. And then from there, I moved to Internet Security Research Group and Let's Encrypt. That was a super really awesome job. They are the creators, they're the largest certificate authority on the web, Let's Encrypt is, also creators of the ACME protocol. This is my first job in pure authentication, so that was pretty awesome as well. And if you haven't checked out any of the other Internet Security Research Group projects, if you're just I use Let's Encrypt as an API call, don't we all? So definitely check out their other stuff too. They're working a lot in memory safety right now, which is really awesome. for all the people who were affected by the CrowdStrike outage. That was a lot of memory safety. And so it's something that, again, a boring part of infrastructure and things that we don't talk about very much, but something that is entirely what we should be talking about because it can affect millions of people on a given, what was it, Thursday? Whatever day that was. And then from there, I worked with the Linux Foundation at Let's Encrypt and ISRG as well. And then I moved to Small Step, which is a startup that does authentication. I'll talk a little bit more about that later, and what their open source offerings are. And then I found myself now at Authsed, so moving into the authorization, kind of like the next step in boring technology. So that's where I've spent my 40 hours. So what are we going to be talking about for the next 20 plus minutes? Authentication and authorization, Auth-N and Auth-Z. I couldn't believe when I first started working a little bit more in authorization how close these two concepts are, and how we're still doing these things really poorly in a lot of our applications and environments. So that's really, since the birth of authorization and authentication and modern computing, which is, as you'll see, in the early 60s and 70s, I mean, that's like almost 60 years. And we still are doing these things incorrectly. So that's what we're going to be talking about today. A table of contents, just because I am this person. Defining both of them, talking through the history. I really believe that history can inform us and our systems, and how we authenticate and authorize our systems. So looking back and seeing like where we were and where we are today. And then also free and open source tools, because every person that runs things loves free and open source, rightly so. So getting right into it, defining authentication. So authentication, or Auth-N, is the verifying the identity of a user, process, or machine, very basically. So we can use one or a combination of three factors, and there's a few more coming up, but for the most part, these three factors. Knowledge, so something a person knows. So this could be like your password, username, combination, a passcode or a PIN, or a security question. Not my favorite one. But next one is ownership, so a physical token or something a person owns. These are your YubiKeys, your hardware compatible of an encrypted handshake, like Acme or an Apple device, or like a Google Authenticator. And then we also have inherence, which is a vital piece of something a user does or is, so biometrics, keystrokes, that kind of a thing. Whenever you sign into social media, or your email, or any web-based application, or even your environments, often, hopefully, at your jobs, you are using some method of authentication to prove who you are, or to prove your machine is what it is. All right. And then authorization, Auth-Z, on the other hand, it's amazing how many people get these, even just in like everyday conversations, get these two mixed up. So authorization is when one entity grants permission to another entity to engage within or with a resource within a certain set of boundaries. So this is like the next step after authentication, right? We have to have authentication, we have to do authentication well, and then we move to authorization and try to do authorization well. Authorization is a thing. It's a big thing. So we have a few different models that we use in modern computing, some more than others. We'll get into them a little bit later as we go through the actual timeline of authorization and modern authorization. But we have RBAC, which is role-based, PBAC, which is policy-based, ABAC, attribute-based, and REBAC, which is relationship-based. I just like saying it like a rapper, like REBAC. All right, so if we think of authentication and authorization in terms of something we interact with regularly in the real world, we can think of it like taking a trip to another country, right? You need a passport to verify that you are who you say you are. But you also need a visa that gives you permission to enter the other country, and sometimes to do a certain thing in that country, right? Whether it be working or being a tourist or whatever. So think of authorization and authentication like that. Authentication is your passport, authorization is your visa. All right. So when we think about that in modern computing or in computing in general, same kind of idea. As a user or a machine or a server or whatever, you are saying, hey, I am a user of this application, and here's how you know. It's my combination of one of the three factors, right, that we just talked about. And the app comes back and says, awesome, hi user, because I know now that you are this user, I can give you access to the things I'm supposed to give you access to. And that's authorization. All right, so first let's talk about authentication. I love digging into history because I'm a total geek about this kind of stuff. I think my slide didn't update, but so authentication had its beginnings in the 1960s and 70s. We had our mainframe computers, and mainframe computers had terminals, and terminals needed to send data back to the mainframe computer and all that kind of stuff. So we needed a way to keep files private, and so enter passwords. A huge shout out to a lot of, I know a few of the faces from those early days of technology here in Minnesota. U of M, University of Minnesota, had an incredible, just an amazing program with those early days of computing and did a lot for early and modern computing. So shout out to anyone who's watching this or who's here, who were here in those early days. And then in the early 70s, technologists realized that passwords weren't enough. And so they came up with the idea of hashing. And so hashing is just transforming any given key or string of characters into another value. Super simple, not anything too crazy. But then, of course, not even hashing was good enough. And so then we have RSA and public key infrastructure. Or specifically, a public key cryptography system wasn't quite PKI yet at that point. So machines and servers at that point in the mid-70s, it's crazy how long it's been around. So mid-70s, machines and servers could use cryptography for authentication. So this state is particularly mind-boggling to me just because it has been around so long, but it took us how long to encrypt the web? I don't know how that happened. All right, so then in the 80s, we have the emergence of OTPs. I remember my first OTP token. I'm sure we all do, and probably for online gaming for a lot of us. But OTPs, complete with the fobs that we got sent in the mail, took authentication to a whole new level. And then in 88, we have the emergence finally of X509 certificates. And so that's when PKI really became a thing. Public key infrastructure really became a thing. And then in 95, secure sockets layer, so SSL, was invented. The 90s were actually just a really amazing time for authentication in general. Technology was growing rapidly, authentication had to grow rapidly. They were like, let's do this thing called SSL, later replaced by TLS, mostly by TLS. And the first SSL, technically SSL v2 certificate was used by Netscape. And I love, there's an online publication, and they're a publisher, actually. They write books as well called Feisty Duck. And they explain this I just love how they explain what the first SSL certificate online was used for. It was to support the web as a hot new commerce platform. So that made me laugh. I was just like, yep, that's what the web does, right? But the mid-90s gave us CAPTCHAs, which, love them or hate them, they're likely the most widespread example of inherence as a way to authenticate. And then in 97, all the way back in 97, Bruce Schneier, who is an American cryptographer and calls himself a public interest technologist. If you've ever read The Cryptogram or any of his work, Data and Goliath, one of his books, he's an incredible technologist as well. He invented the very first password manager called Password Safe, all the way back in 97. And still, for some reason, we cannot get our parents using password managers. And then This is also an incredibly, I don't know how many of you were around technology yet in the late 90s, but Active Directory came out in the late 90s. And so instead of a username password, we have SSO finally. Well, not finally. It was actually a really novel idea in the late 90s. And so Active Directory came out. A lot of us still use Active Directory today, which you'll see it come up several times coming up here. So yeah, Active Directory, still going there. Sorry, I just lost my spot. There we go. And then in the 2000s, more of the world came online. Finally, we're getting online. And we need more authentication, not just Active Directory anymore. We need SSO in a big way online too. And so we need more authentication, enter multi-factor authentication in the early 2000s. In 2009, one of our favorite ways to authenticate a machine was invented, so the TPM. I've had a really good time watching people break TPMs since they came out. So, play around with them, take them as you will. They're kind of cool. They're kind of a fun and novel little thing that we sometimes use to authenticate hardware. And then in the 2010s, we see the emergence of biometrics and behavior-based authentication like keystrokes. Still things that we use today in a lot of environments. All right. I promise I'm almost done with authentication. I really like this topic, as you can probably tell. So in 2016, one of the biggest ways that we as technologists can make sure that we are using technology that is widespread and can be used in several different places across the web, across applications, is standardization. Standardization is super boring, turns out. And it's a bunch of technologists sitting and ruminating about various things, but they're various things that affect the food we eat and how that food gets to us, and how the water and our infrastructure is set up, things that we need every day. Standardized protocols and standardization affects all of that kind of stuff. So it was super important to start standardizing web authentication. And so W3C started doing this with web authentication, just to standardize again those web-based applications and how users authenticate themselves specifically on the web. So there are other protocols, like RSA and cryptography that has been more standardized. But at this point, this was when they said, hey, we need to do something for the web as a whole. And so then that brings us to now. So in the 2020s, authentication became abundant. So MFA was available almost on all web applications. If you are using a web application that doesn't have MFA, don't use it. Straight up, do not use it. If you are running an application that does not have MFA, we are going to have words. And then we have over 25 password managers available now, which is, since '97 when Password Safe came out, over 25 available. Still can't get our parents on them. Single sign-on has expanded past just Active Directory. We have Google. We have all these other things. Meta does a great job with SSO. WebAuthn is now implemented by companies like Google and Apple with passkeys. I'm not even going to talk about passkeys on this one because I will totally nerd out. But passkeys are super cool and an upcoming technology too. Actually, kind of circular technology, but being more widespread and more adopted now. And then we also have device authentication, making progress with various PKI implementations, specifically looking at the ACME protocol and how it's used in various environments. Apple's doing really big things with this, with their just everyday devices, which is pretty cool. All right, are you ready for this? Now we're going to go through authorization. So now that we've been through authentication, we've talked about that process a little bit of getting to the point where we are now to authenticate a user. Now we're going to look at authorization and the history of authorization. So, yep, and again, just authorization definitions up there. So we look back, started around the same time. It's amazing when somebody was like, oh yeah, I need to identify a user, but I also need to tell the user what they can actually look at, is actually really helpful. So we have that mainframe era again. So it was pretty rudimentary. It was ACLs. We still use ACLs a lot today. So no shame in using ACLs by any means. We still use ACLs for a lot of various things. A lot of environments are developer environments. Totally an okay thing to do. They've been around a long time. They're kind of a tried and true method. So that was one of the earliest ones to really start digging into authorization using those mainframe computers. All right. Role-based, so that's RBAC, came around in the 80s and is still used today by many systems. So this is the idea. RBAC is actually the idea of permissions are given to a group instead of just a user. So the permissions are given to a group. The user assumes the permissions of the group. And that's RBAC in a very small nutshell. And then we have the 1990s. We have policy-based access control. So this starts to take shape because we're starting to have more applications. We're starting to have more things that need more nuanced authorization. And so the 90s didn't see quite as much. You can kind of tell, even just in this timeline, authentication took off a lot faster and had a lot more people working on it than authorization has. Even just like, we have all of these different permission systems and all these different styles of doing permissions, but there hasn't really been like that one thing, where we're like, yeah, cryptographic handshakes in authentication, right? There hasn't necessarily been that one thing in authorization that's like, yeah, this is the way to do authorization. And so we have all these various sets of permission systems. We're still using ACLs, for goodness sakes. So we don't have like that one thing where we're like, yeah, authentication really took off. And is a mostly solved problem, quite honestly. We're still kind of going through that with authorization. So the 90s, when authentication was booming, right, where authorization's like, here's policy-based access control, which is cool. It's a super cool thing. So it's like where access decisions are based on a set of rules or policies rather than static permissions. So it's easier to update. You can do more fine-grained things with it. All right. 2000s is ABAC. So essentially, again, moving a little bit slower, but we're like, okay, policy-based is cool. We still use systems that have policy-based, but we also want to do attribute-based. So getting more granular with our permissions, with how we're defining users and groups, things like that with ABAC. Oh, also web applications came on the scene about that same time. So they were like, oh, my users need attributes. So here is the 2010s and other technologies. Mainly the emergence and quick adoption of APIs forces us to think about what authorization can look like, not only for us, but for those third-party applications as well. So we, as people who think about security and run applications, we're like, hey, third-party applications also need to do things on behalf of a user, right? And so how do we give those third-party applications the permissions that they need? And so OAuth 2.0 became a thing in the 2010s and allowed people to do that. The mid-2010s saw the emergence of RBAC, and that's kind of where it has stopped for what we're doing today. So mid-2010s, it's basically an extension or evolution of ABAC. Like a lot of these all kind of, learned from each other, grew on each other and things like that. So RBAC, relationships between entities, so like users, resources, environments, things like that, are used for permissions rather than just attributes or roles. And that's, again, kind of where we stop today, is really with relationship-based. So 2019, the Zanzibar paper comes out. So in typical Google form, we are like, we love what Google does. We all want what Google does because they do it pretty well most of the time, except for when they get rid of things. But somebody made the comment, they're like, they're going to get rid of Google Slides. And I'm like, please no. I don't know how to work anything else. Their permission system isn't going anywhere. They have done an extensive amount of work to make sure that users are getting permissions to the things that they should be seeing. And their permission system is huge. It's a behemoth. If you think about a permission system that can give permissions over so many environments and clouds and applications like Google has. It's a huge permission system. So they came out with this white paper called Zanzibar. Then they were like, here's how we do it. But we're not actually going to give it to you because we're Google. So they came out with a white paper in 2019 called Zanzibar. It's a global authorization system. And people went and started iterating on that paper. So that idea of like Google infrastructure for everyone else became a reality for authorization. It was actually a pretty big turning point in that reback timeline. So then we have the 2020s. It's sad that like this is something I have to bring up because like authorization just hasn't gone very far, but the blockchain. So there is still things going on with authorization past reback, but it does have to do with blockchain and decentralizing models for authorization. Actually, this is a really novel use of the blockchain, so I could totally see like as reback and as like the Zanzibar implementations start coming more online and more people start using them other than just Google, I could really see like that model being put essentially on the blockchain and using kind of a decentralized authorization system. So kind of, again, like what we have seen in authorization throughout the years of building on each of the backs and kind of, continuing that process into decentralization. Okay, so that was a bit. We are now, what does this look like in practice? This is what you all want to know. And this is probably what a lot of you already do know. But in case you don't, there are things that exist today, tools that we can use. So let's say we're looking at authentication tools first. So let's say we're getting back to like those basics of authentication, which is that cryptographic handshake. What can we use to satiate a cryptographic handshake? So I love my API calls. We can, of course, use Let's Encrypt as it's just an API call and to get a certificate, and that satiates, authentication in that way. So let's say, though, that, you all are the doers and the people who run these things. Not everybody wants to not everybody wants to use something on the web for running their own applications, and I totally understand that. Let's Encrypt, I would not suggest using Let's Encrypt unless you're doing unless you're creating a web-facing application. Let's Encrypt it is totally open, and it's open source technology, so they do have their certificate authority out there in the world. It's a behemoth. It is web size. It is billions and billions of certificates kind of a thing. So if you want to run a CA, your own mini CA in your own environment, don't use the Let's Encrypt CA. I would strongly say don't do that. But there's other ones that you can use. So there are like little mini CAs that exist in the world and that are free and open source. So we have EJBCA by Keyfactor. This is an open source CA with a really solid quick start guide, especially for containerizing your environments or using containers in your environments. You can get this up and running in literal minutes. So it's kind of cool. Running your own little mini CA for authentication for your users is pretty easy with that. I hesitated to put this one on there because I haven't actually used it. But OpenXPKI also exists. Again, I haven't used it. I've talked to a few folks who have, but I've heard pretty good things about it. One of the things that I always look for when trying to figure out like what kind of technology I want to use, especially in the open source space, is like, is the project well maintained? Like, when was the last time they had a release? And then also, does the project have a good community around it? Like, I want to use a project that has open source support as well, because that's where you see a lot of, like, that's where you get answers even faster than like actual enterprise support a lot of the time. So OpenXPKI has a pretty good community support option as well. I have heard from people who have implemented it in their applications in the past that it is a very, very quick slide into their paid things. So take that as you will. Use it if you want. But that's where that goes fairly quickly. And then small step, again, a little bit biased as I worked there. I worked there, though, specifically because I liked the technology. Has an open source certificate authority offering as well called StepCA, and it is robust. And I like running it. I still run it, even though I don't work there anymore. And it's really easy to use, really easy to download to get started. Doesn't have quite the documentation that even OpenXPKI has. So they're still working on that. But the README on the GitHub is great. I'm going to tell you pretty much exactly what you need to run it. So StepCA is pretty awesome as well.
The CLI and Helm chart are awesome.
You know it. Yeah, the CLI and Helm chart are pretty cool. As someone who has ran small step, and yeah, definitely. So we move to authentication tools that can actually help us run things. Let's say you already have an identity provider, and you're like, okay, now I need this identity provider to integrate with my application. So there are ways to do that. Again, recognizing my bias, we created DEX at CoreOS, but DEX is still ubiquitously used, 10 years later. So if you're looking at using OIDC, or OpenID Connect is what it's called, as for authentication for your application, I would strongly recommend using DEX. It's a piece of software that doesn't need to get updated regularly, which is like a crazy thing to think about. So it's now part of the CNCF landscape, and you can use it to allow your application to plug into any upstream identity provider, but only implement OIDC, which is actually really helpful from a security standpoint as well. So the point of all of this is, again, to use that to get SSO to your users, and you can use DEX to do that. LDAP, of course, the Lightweight Directory Access Protocol, is a standardized protocol that can store information about users, groups, and applications in their directory server. So you can use services like OpenLDAP to actually help you use this protocol. Again, all open source, all available and free. And then we also have not open source and not free. But I had to mention it because Active Directory has been such an incredible authentication tool for so many years, and it's a behemoth in the room that we all know and that we all work with on a daily basis. So Active Directory is in there. It's not altogether terrible. It's a little terrible, not altogether terrible, but it's stood the test of time, for better or for worse. Okay, that's all I'm going to say about that because that's not open and free. So again, recognizing my bias, Reback came into the picture, Zanzibar came into the picture. I work at Ofsted now. Ofsted said, hey, we're going to create SpiceDB just because we want, we've run into this. We know that these things, that authorization is not fixed yet. And so SpiceDB is a Reback implementation. Totally free, totally open source. Go play around with it. It's pretty cool. So they just give you the heck out of it. And then we also, I would be remiss if I did not mention OPA, the Open Policy Agent. So this is actually a graduated CNCF project, which I don't entirely know what that means, but it's a graduated CNCF project that is maintained now by Styra. So it is still open, it is still free to use, but it's maintained by a certain company, but it's also a CNCF project. I don't know, whatever. So you can, of course, use OPA for that, again, relationship-based access control. So, all right, that was a lot, and I think I'm over. So that was a lot of information. Oof, that was a lot of information. I co-authored a blog about this just because I'm a nerd and wanted to. But then we also have, so you can check out that blog post. We also have Feisty Duck. I absolutely love Bulletproof TLS. I love the current rendition of it. He updates it regularly, new versions of it. It's a really, really great, if you're looking at getting into authentication and cryptography, it's a really, and folks who just use that, it's a really great way to actually know TLS. And then we also have the GeekWire's history of authentication, which I used a lot from, and then just added things from my own brain to make the timeline. I did check my sources, of course. But so that's another thing that I used. So if you have any questions or comments, please come find me after this. I love talking about this stuff, obviously, and have spent 10 years doing this kind of work. So you can look me up on LinkedIn if you don't want to come talk to me. I know that can be weird. Or you can find me on X, I guess, if I have to be there, at JPN Tech. And thank you again to all of the DevOps Days coordinators. We missed this so much last year. My heart was so sad when I was looking for it. I was like, where is it? Why are we doing this year? But thank you to all the coordinators for making it happen again. This community would not be what it is without you. And this community powers the food we eat, the places we shop, the flights we take, and everyday things. And so just thank you again to the coordinators of all of this, and thank you, all of you, for being the change makers. I firmly believe that DevOps folks are the people who get the stuff done. So thank you for being like that line of defense and security, and for taking security and authorization and authentication into your workload. But yeah, so thank you.